Hi, my name is Zada. In this video, I shall discuss the Orgel diagram. Orgel diagram was first developed by Leslie Orgel in 1955. Orgel diagrams explains the splitting of d orbitals into Eg and T2g. The d orbitals d consists of 5 orbitals in pre-metal ion. All these orbitals are degenerate. Degenerate means have same energy. Whenever ligands come toward metal ion, the energy of these orbitals become different and it change into different groups. Eg means doubly degenerate, a group of 2 orbitals having same energy. Eg consists of dx square minus y square and dz square. T2g means triply degenerate group, a group of 3 orbitals having same energy. It consists of dxy, dyz, dzx. It is the graphical representation of the excitation of electron from one energy level to another energy level. Graphical representation means in the form of graph, in the form of x-axis and y-axis. Orgel diagram shows that how the energy level of transition metal atom splits when it is placed in ligand field. Ligand field means any chemical species which donate electron to central metal atom. As ligand come toward transition metal atom, the orbital of d subshell or any energy level divide into various groups on the basis of difference in energy. In order to explain the Orgel diagram, consider D1 system of octahedral system. Any metal ion which have one electron in its valence d subshell. Octahedral system means in which transition metal attached to 6 ligands. The term symbol for D1 system is D2. D2 means that it will split into 2 energy level Eg and T2g. How this D2 comes for D1 system? 2 represents spin multiplicity. The spinning motion value for one electron in d subshell is half. Spin multiplicity is equal to 2s plus 1. So 2 multiplied by half plus 1 is equal to 2. This is spin multiplicity. 2 is the spin multiplicity. And how the capital letter D come? D is present in third shell. So the L value per D is equal to n minus 1. N represents shell number. 3 minus 1, it is equal to 2. So for capital S, the value is 0. For capital P, the value is 1. And for capital D, the value is 2. If 2 come, then we represent the letter capital D. So D2 means it will split into 2 energy level. This is d orbital in metal atom. When ligand come toward metal atom, the orbitals divide into 2 groups. One is Eg and the second is T2G. This is vertical axis which represent energy. As ligand come toward central metal atom, the orbital of d subshell and its valence shell divide into 2 groups, Eg and T2G. Eg is of higher energy and T2G is of lower energy. Why the energy of Eg is higher and the energy of T2G is lower? Eg consists of 2 orbitals dx square minus y square and dz square. Its lobes are along x-axis, so ligand come along x-axis. Due to inter-electronic repulsion, its energy become high. T2G consists of dxy, dyz and dzx. The lobe of these orbitals is present between axes. So ligand can't directly come along these lobes, but ligand comes along x-axis, so the inter-electronic repulsion is minimum, and that's why the energy of these orbitals is lower. Now how we can represent this through Orgel diagram. This is the graphical representation. In graphical representation, this is 2D, which represent term symbol with spin multiplicity. In center, we write this term symbol for pre-metal atom ion. For pre-metal ion, this vertical axis represents energy As the ligand come toward pre-metal ion, the energy of d orbitals become different and it divides into two groups, T2g and Eg. This is also form of crystal field splitting. As we move from left to right, it shows ligand field strength. For D subshell, D1 subshell, we write one electron here. As we give energy to this electron, it goes into excited state Eg and show one peak in the spectrum, absorption peak in the spectrum, because in D1 only one electron excitation occur. Eg and T2g are written for orbitals. Small eg and small t2g are written for orbital. Capital Eg and T2g are written for electronic transition. This is the spectrum which is shown by D1 system. In D1, only one electron excitation occurs, so it shows one peak in the spectrum. Orgel diagram explains the splitting of d orbital by weak field ligand. Weak field ligand means those ligand which can't donate its electron easily due to its high electronegativity, and not that of strong field ligand, which is explained by Tanab-Sogano diagram. Orgel diagram explains the splitting of d orbital by weak field ligand, and Tanab-Sogano diagram explains the splitting of d orbital by strong field ligand.